So today we want to discuss epsilon delta definition of continuity of limit basically. So here essentially we are discussing function of two variables, but these ideas we can extend for functions of three variables also. So let us start with the definition. So let we have a function f defined on the domain D. So domain here means it is a subset of xy plane. So f is a function from D to R, be a function where 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 the domain D contains points which are arbitrarily close to the point AB. So if A comma B is a given point of xy plane where we want to find the limit of the function. So we say that the function has limit L as xy approaches to A comma B if the following condition is satisfied. So the following condition is that for every, so this is definition of limit, for every epsilon greater than 0, there exists delta greater than 0. So this was earlier also in one variable case. Now in one variable case, what we had is basically modulus x minus a is 0 less than modulus x minus a less than delta. So that thing we need to generalize here for two variables. So that is basically distance of x and a was less than delta. Instead of that, we will get the distance of xy and point AB is less than delta. So that means the condition is 0 less than square root x minus a square plus y minus b square less than delta. And of course, our point should be in the domain, right? So whenever the distance of x, y, and AB is less than delta, that implies that the value of the function is as close to L as we like. So that means whatever epsilon we choose, the value of the function will be epsilon close to L. So this is definition of the function, limit of a function at point AB. And of course, notation we use as limit xy approaches to AB or tends to AB if of xy is L. So again, here also the points AB may not be in the domain, right? Where we are finding the limit, that point is not required to be in the domain. But all points near to that point should be in the domain so that we can approach to that point. So what we basically have is we have a domain D in which we have a point a comma b where we are finding the limit of a function. So our function is from D to real line, and real line we have a number L. So whenever we take an epsilon neighborhood around L, whatever epsilon we choose, we need to find a delta such that this square root x square minus a square plus y minus b square less than delta. So that is, we know that is the equation of the circle, right? Inside of the circle, because we are taking less than delta. So this equation is x minus a square plus y minus b square less than delta square. So this is circle with radius a comma b, center a comma b, and radius delta, right, inside this circle. So interior of this circle, we have to choose the point. So we have to find a delta around. Delta will be the radius of the circle, center at AB, and we'll take all the points inside this circle. So that is basically this condition, excluding a comma b. Whenever we take all these points and apply the function, the value of the function will lie between L minus epsilon to L plus epsilon, right? So that is this condition that f of xy is between L minus epsilon to L plus epsilon. Right, so this modulus f xy minus L less than epsilon means f of xy lies in the open interval L minus epsilon to L plus epsilon. So this is basically the meaning of the epsilon delta definition we extended for two variable functions. So now when we want to find such a limit at for example at the origin, so for example our point is 0 0 and we want to approach to 0 0, our point xy approaches to 0 0. There are several ways through which we can approach to origin. One way is that we can use the iterated limits. Iterated limits I have mentioned in the last lecture. So we have the point xy. So first we will project it on the x-axis, right? So if you project, then basically what we are taking is y equal to 0. So we are applying the limit y tends to 0. So our point approaches to x comma 0. And then we can take x approaches to 0. So now xy will approach to origin. So this is the one path along which we are approaching to 0 0. We are taking the limit along this particular curve. The same way we can first take y approach to 0, then we'll come at the point so am I right? I have done correctly or not? Yeah, so I should write here x approaches to 0, then our point will be 0 comma y, and then we'll go for y approaches to 0. That will, so we will go from 0y to 0 0. So whatever xy point is given, if we take these two limits, we will always approach to origin. So these limits are known as iterated limits. Right. So what are the iterated limits? Iterated limits are, first we will take limit y tends to 0, and then we'll take limit x tends to 0 of the function. So this is first iterated limit, and second iterated limit is limit x approaches to 0, limit y approaches to 0 of the given function. So this is kind of finding left limit and right limit in the one variable case. So these are two different ways to approach the origin. The other possible path is possible path along which given point xy approaches to 0 0 is y is equals to mx. So y is equals to mx means we know that we have a point, for example x comma y is here, and it satisfies this condition, y is equals to mx. So y is equals to mx line is uh, more or less the graph will be of this type, right, depending on what m we are choosing. So along this line, if we substitute in the function y is equals to mx, then our function will become x comma y, that is x comma mx. So now it is a function of only one variable. So therefore, along y is equals to mx, basically we need to find the limit of f of x comma mx. Now there is no y, so essentially it is only one limit, that is x tends to 0. So these are some of the paths along which we can approach to origin. So like in the one variable, there are two paths we are taking, left limit and right limit. And we know that if left limit and right limit of functions of one variable is not same, then the limit does not exist, right? So that is what we will essentially conclude by these paths. But we know that every time it does not hold in one variable function, so sometimes the limit may exist, and whenever the limit exists, we apply the epsilon delta definition to prove the limit actually exists. So let us see the examples where we can apply these paths, and along all these paths, suppose the value of the limit is same, then possibly the limit exists, and in that case we will use epsilon delta definition to prove that is actually limit or not. So that is the basically method. First apply by different paths. If the limit is different, then limit does not exist. If along all possible paths the limit is same, then there is a chance that the limit is actually exist, and whenever limit exists, we need to prove by only one method, that is epsilon delta method. Of course, the sequential method also we can use using the squeeze approach, which we discussed in the last lecture. So let us discuss one example that show that limit xy approaches to 0 0 of the function x square minus y square divided by x square plus y square does not exist. So we want to prove this, right? So here it was in the question itself, it was given that we need to prove that it does not exist. So whenever we want to prove the limit does not exist, we need to find two different paths along which the limit is different. So first we'll apply the iterated limits. That is our first step. So let us find the iterated limits. So first iterated limit is limit x tends to 0, limit y tends to 0 of the function. So function is our basically it is x square minus y square divided by x square plus y square. Right. So essentially this limit means there is a bracket here. So first we will apply y approaches to 0, and then whatever we will get we will apply x tends to 0 on that particular function. Right. So if we apply y approaches to 0, what we will get essentially is the bracket becomes x square divided by x square. Right. And since x approaches to 0, x is a non-zero number. Right. Now we have a limit in terms of function of one variable. So limit x approaches to 0, x square divided by x square is 1. And then limit of a constant function is always the same number. So limit is 1 in this case. So the other iterated limit is limit. First we'll apply x tends to 0, and second we apply y tends to 0. So limit of the bracket will become now x tends to 0. So if in function if we substitute x equals to 0, it will become minus y square divided by y square. And then we know that again here also limit y approaches to 0, we have the limit of minus 1, and that is nothing but minus 1. So we can see that in this particular example, one iterated limit is 1, the other iterated limit is minus 1. So essentially what we have proved in the diagram is that if we approach along this curve, and if we approach along this curve, approach xy to the origin along the second curve, the limit of both these curves is basically different, right? So that is what we proved here, that along the one curve the limit is 1, along the other curve limit is minus 1, and we know that limit is always unique. So since if the limit exists, it should be unique. But here we are getting two different limits. Two different limits. So therefore limit does not exist. So this is essentially the first example which we have discussed, where the two iterated limits itself are different, and therefore limit does not exist. So let us see one more example of this type. So find the function, find the limit xy approaches to origin of the function 3x square y divided by x square plus y square if it exists. So now the question is whether the limit exists or not. That is first question. And the second question is, if it exists, what is the value of the limit? And the next thing is that if we can guess that value of the limit, we if both the iterated limits are same. Just let me check my voice. Am I audible now clearly? Okay. Okay, so let me so let me once again revise the process. So what we do first is we will find the iterated limits. The second step is we will check along the y equal to mx path, and the third, if none of this path will work, we may go for the epsilon delta method. Yeah, so what will be the iterated limit for this example? Just find out it. Both the iterated limits I think will be same in this example, right? What will be the limit? So just take x tends to 0, then y tends to 0, and y tends to 0, then x approaches to 0. Okay, so let me do that once again if you want. So the limits of this function, the iterated limits. So first, if we substitute y tends to 0 here, what we get is the denominator will become x square and numerator will be 3x square times 0. So that means the value of the function is 0 in the bracket. And then limit of the constant function 0 is 0. On the other hand, we have the second iterated limit, that is limit y goes to 0, limit x approaches to 0, 3x square y divided by x square plus y square. So here also, when we substitute first limit x tends to 0, the value of the function will be 0 divided by y square, and that is 0. Right? That is limit y approaches to 0 of the 0 function, and it is nothing but 0. So both the iterated limits of this particular function equals 0. So if the iterated limits are different, then we can conclude that the function has the limit of the function does not exist. But now here it is equal. So along both the paths, the limit is same. So note that both the iterated limits are same. So since both the iterated limits are same, we cannot conclude the function to be has a limit. Sorry, the limit does not exist. So the next step which we have mentioned here is that we need to check the along the different paths. So that is along y equals to mx. So let us see along y is equals to mx whether we are able to get any different limit. So along the third path, y is equals to m times x. We get the limit. So what limit we get is limit basically when we substitute y is equals to mx, we get limit x tends to 0 f of x mx. So we need to substitute y is equals to mx here. So that is when we substitute in the function, our function is basically 3x square y by x square plus y square. So there we substitute y equals to mx. So 3x square mx divided by x square plus y square. Y is mx, so mx square. Right. So just substituting y equal to mx in the function, we are getting this value, and then we can see that what we can do here is we can the highest power of x in the denominator is x square times 1 plus m square. In the numerator it is 3m x power 3. So when we cancel x power 2, essentially we get 3mx divided by 1 plus m square. So whatever m we take in the y equal to mx line, so whether we take y equal to x line for m equal to 1, y is equal to 2x line for m equal to 2, whatever line we select, our limit always will become 0 for all m, right? So even we change m or we change the line y equal to mx and approach along that line to the origin, the value of the limit is same, 0, nothing else. So we are applied different paths every time we are approaching the limit is 0. We are unable to show that limit does not exist. So now we can guess that it may happen that the limit actually exists. And the question is, what will be the value of the limit in that case? Suppose the limit exists, then what is the limit of the function at origin? So that is coming from this computation basically. So every time we can see iterated limit is also 0 along y equal to mx, also we are getting limit is 0. So therefore we are basically guessing that the limit of the function is maybe actually 0. Right, so let us write down this thing, kind of remark that along most of the test paths, basically the limit of a function, given function, approaches to the value 0, right? So therefore we suspect that, we guess that the limit of the function may exist and the value of the limit may be 0. Right, so 0 we are guessing because of we have found the iterated limits and limit of the function along the path y is equals to mx. So now we have a claim that we whether we can show that xy approaches to 0 0 3x square y divided by x square plus y square is the value of the limit, that is 0. So this is our claim. So can we prove this? That is a question. And as we know that whenever we want to show limit exists in one variable, here also the method is that we need to show using the epsilon delta definition, right? And whether we are proving the epsilon delta method or using the sequence approach that the limit of the function exists, we always use the squeezing idea, right? So basically the given function we try to squeeze and show that it is less than epsilon by choosing delta. So let us see how we do that for this particular epsilon delta method. So we start, let us write down what we want to prove. So let epsilon greater than 0, we want to find positive number delta, that is fine. The condition is fxy minus L less than epsilon. So function is 3x square y by x square plus y square minus limit is 0 in this case, that is what we want to prove, that is less than epsilon. And this we want to prove whenever 0 less than square root x minus a square plus y minus b square. So here AB point is 0 0 because we are approaching xy approaches to 0 0. So therefore this becomes x square plus y square less than delta, right? So this is essentially we want to prove. If we can prove this, that means our function has limit 0 as xy approaches to 0 0. So what we will do is we will basically try to squeeze this function by this quantity. All right, that is basically our plan. So we try to squeeze the function. So now basically it is function means basically this thing which we want to show less than epsilon. So this quantity we want to squeeze in terms of this quantity. And then we know that square root x square plus y square is less than delta. Then we can compare epsilon and delta basically. So let us try to do this. So to do this, there are several methods. Either we can use AMGM inequality for one variable. Usually we have done that. And we can use some inequalities like sin x function is modulus is less than equal to 1, those things. So here what we can do is we know in the numerator the power is x square and in the denominator the power is x square plus y square. So we know their relation that x square always less than or equal to x square plus y square, right? So that we can use here. So if x square is less than equal to x square plus y square, x square divided by x square plus y square less than equal to 1. So therefore this is less than equal to 3 times modulus of y. So why? Because x square by x square plus y square is a non-negative term. It is less than or equal to 1. So this thing we use here, and we want to still squeeze this function basically by such a quantity. So what shall we do is, we know that again using the same quantity, y square is in terms of y square is less than or equal to x square plus y square, right? So this is nothing but 3 times square root of y square, because square root of y square is modulus of y, and then we know that y square is less than or equal to x square plus y square. So essentially we are using the same similar inequality, that instead of x square is less than or equal to x square plus y square, we are using y square is less than or equal to x square plus y square, and then we know that this quantity is less than delta, right? So this quantity is less than delta. So if we choose our delta to be epsilon by 3, then this quantity will be less than epsilon, because finally what we want is modulus of 3 times 3x square y divided by x square plus y square is less than epsilon. So that is the reason we can choose delta to be epsilon by 3. So therefore choose delta to be epsilon by 3. So therefore what we get finally is that for 0 less than x square plus y square less than delta, what we get is 3x square y divided by x square plus y square less than epsilon. So therefore limit exists, and it equals to 0 in this case. Yeah, so if you have doubt, you may please ask.
सर ये सर समझ नहीं आया सर.
Which particular part?
सर ये आपने सर ये एप्सिलॉन इज इक्वल
डेल्टा कैसे लिया?
इक्वल्स टू एप्सिलॉन बाय 3 करा, फिर उसके बाद ये कैसे प्रूव कर दिया कि ये लेस देन 3x स्क्वायर बाय x स्क्वायर प्लस y स्क्वायर लेस देन एप्सिलॉन होगा?
So basically we got this function 3 modulus of 3x square y by x square plus y square less than or equal to this quantity. We know that x square plus y square is less than delta. We want to choose such a delta. So that means what? This will get less than 3 times delta, right? So this quantity we got, which is less than 3 times delta, if we choose such a delta.
आ गया सर, आ गया.
Right, and then we know that this we need is less than epsilon, so that means basically we are selecting. So this I can write in bracket kind of thing. So this is the idea basically. So essentially what we use is, we use the inequality for the squeezing is x square less than or equal to x square plus y square, and y square less than or equal to x square plus y square.
सर ये स्क्वायर रूट ऑफ एक्स स्क्वायर प्लस वाई स्क्वायर कैसे लिया था हमने?
Square root of
ये एक्स स्क्वायर प्लस वाई स्क्वायर
कैसे लिया था? Okay, so that is coming from the definition of limit. Let me go directly there. Yeah, so what is the definition of limit? So if you want to find the limit xy approaches to a comma b, we take this particular equation. 0 less than square root x minus a square plus y minus b square less than delta.
Okay, sir. वो क्या मैंने late join किया था इसलिए
So
late हो गया.
yeah. So we are basically finding limit xy approaches to 0 0 here. So that means a is 0 and b is 0 here. So that is exactly 0 less than square root x square plus y square less than delta, because a is 0 and b is 0. So that is what we have written here, that yeah, so this basically we need to check here. Okay, so let me give one or two kind of exercise if you want to practice. So just check the limit of these functions at the origin. The f of xy first function is xy divided by x square plus y square. Second function is fxy xy square divided by x square plus y power 4, right? So check limit at origin if exist. So I think this would be enough